Everyone, thanks so much for joining us for the third lecture in our virtual course on environmental economics. We are delighted to have Esther Duflo here to talk about climate adaptation. Before I turn this over to her, let me just remind you of a few details. First, if you're interested in having your camera on and joining us live, please put up your hand and we'll select a few of you to do that. Second, for logistical questions that you have, to access recordings from past lectures, to access slides from past lectures, please refer to the course website that has just been posted in the chat. You can find answers to a lot of your questions there. Remember to use the Q&A for substantive questions only, questions about content. Save the logistical questions if possible. And after, at the top of the hour, we'll have a 20-minute Q&A session that will pick some of the questions that have been posted and some others to further engage with the content that we hear from Esther. So Esther, let me turn it over to you, and thanks so much for being here.
Hi everyone. Thank you for inviting me to do this lecture. Thank you to everyone for taking the time to be there. I realize people are still trickling in, so I wonder whether I should do some filler while so people don't miss the critical first slides, but I guess I won't do that. So today I'm going to talk about adaptation to climate change, and with a focus, of course, on developing countries. The adaptation is defined as the set of actions that people take in anticipation or in reaction to permanent change in the climate that affects the way they live, the crop they can grow, the activities they can have, the temperature in which they operate, the flood situation in their neighborhoods, and so on and so forth. So obviously it goes without saying that it's a pretty essential human reaction to climate change to adjust to it. How easy or difficult it is to do that, how costly or difficult it is to do that, is one of the central questions we have to think about when we think about climate change for developing countries. I'm probably going to say a few things that either have been said before or will be said later, so I apologize for that in advance. But it is probably worth emphasizing some of the features of climate change. The first one, as you probably all know, is that low and middle income countries are in places where it is already hot. You can see it today. You can see it for today's temperature from this map from the Global Impact Lab that shows the heat map of hotness, so to speak. That is places. The redder it is, the more there are days that are above 35 degrees Celsius, and you can see that you find many of those in sub-Saharan Africa, particularly the Sahel regions in the north of Latin America and in South Asia. So as a result, even though an increase in temperature of 2 degrees doesn't mean that it's an increase in temperature of 2 degrees everywhere. It is still the case that if you're starting with more hot days in the first place, you will experience more hot days in the first, more extra hot days in the first 20 years. So you can see here, the heat map is telling you how many more days above 35 will countries experience, and even more so by 2100, where you're seeing in particular the Sahel region and the north of Latin America, the Pakistan and north of India are experiencing a lot of these additional days above 35 degrees. Why are we talking about 35 degrees as a relevant threshold? It's because it's the threshold at which a lot of things become difficult for the human body to function, difficult for a lot of culture to function, and so on and so forth. So it's kind of threshold after which many things start to go poorly. So because of that, naturally, the cost of climate change will be higher in poor countries, because the cost of warmer temperatures are not linear, or they are not concave. They are very strongly convex, in particular with potentially those threshold effects around 35. That in itself will mean that developing countries will experience larger costs. In addition, and this is what we are going to spend a lot of time today discussing, is the fact that developing countries have fewer tools that will help them adapt to such extra days. In particular, they have less money, and money can buy things like air conditioning or other infrastructure. They have less investments in public good infrastructure, such as electricity and roads and things like that. And they have less developed social safety net. So a summary of today is that the cost of climate change that are likely to be higher in poor countries include both the costs that are related to the fact that the direct impact will be larger, such that the cost of human health and mortalities are in part related to the fact that there will be higher temperature, in part related to the fact that adaptation will be harder. Similarly, developing countries have a lot of coastlines. If you're considering, for example, Vietnam, Thailand, India, Bangladesh, a lot of poor countries are in low-lying areas, which means that flooding is going to be a huge issue. Disasters such as flooding, again, will be climate change is not only an increase in average temperature, but an increase in uncertainty and volatility. That is also likely to be more in countries that are already hot today and that are already subjected to weather patterns such as typhoons and other things like that. So what I'm going to do today is to kind of develop some of these themes. The first thing we need to do is to see whether it is in fact true that the climate impact would be different in poor countries or in richer countries. And if that is the case, we need to think about where it's coming from. So first order, of course, again, there will be more hot days in poor countries, so poor countries will be more directly affected. But at second order, I've made the claim that a given hot day might be more costly, either for mortality or for productivity, for agricultural production and overall GDPs in poor countries than it is in rich countries. So in order to substantiate this claim, I have to first tell you how one would go about measuring climate impacts in the first place. So it's pretty difficult to measure climate impact because it's not that we have a counterfactual. Climate change, by definition, hasn't even happened already. So we don't, it's worse than the typical case of impact evaluation where we at least see the treatment, even if we don't see the counterfactual. Here we see what's happening today, but we don't have the counterfactual yet. So we don't know what will happen. So people have gone to it in various ways. A lot of work is on simulation, so integrated assessment models. Some work is using long differences, so using the past changes over long periods of time. And one of the leading methods is the short-run fixed effect estimates, pioneered by Michael Greenstone, Olivier Deschênes, and others, and most recently illustrated beautifully by a paper by Tama Canton and many, many, many other co-authors from the Global Impact Lab at Chicago. And that's the strategy on which I'm going to spend a little bit of time on. So this strategy is not going to tell us what is the impact of climate change directly. What the strategy is doing is to look at the impact of random variation in the weather around the climate that we already have. So of course, for a given climate, there is a lot of year-to-year variation in the realization of temperature and other features of the weather as well. And we can use those variation to get to try to estimate the impact of those fluctuation in weather on outcomes such as productivity, but also test scores of kids to see whether they're affected by higher temperatures, mortality, agricultural production, GDP, whatever, what have you. So that strategy involves running a two-way fixed effect regression where we are taking a panel data. For example, it could be a panel of districts in India. We are looking at we're introducing district fixed effect and time fixed effect. So that's controls for the climate, in fact, by the district fixed effect, as well as any other fixed characteristic of this district. And then we are using the fact that from year to year, there are variations. Some districts end up being warmer than others. So they might have more days that are above a certain threshold, more days that are above 60 degrees Fahrenheit, 70 degrees Fahrenheit, 80 degrees Fahrenheit, 90 degrees Fahrenheit, and so on. So in this way, we are really asking whether controlling for anything else that is different in a fixed way in this particular district is the fact that this district experienced a number of particularly hot days associated with the fact that there is, for example, more mortality in that district in that year compared to another district which in this particular year happened to not have so many hot days. So that method is being used again and again and again. It has shortcomings. In particular, it really is about, is well suited to look at impacts of temperature, for example, or of small variation in rainfall, but it's not telling us anything about sudden system-wise non-linear changes that could come from climate change. So this is really well suited to look at the direct effect of temperature keeping everything else equal, knowing full well that everything else is not going to be equal. So when we do that for India, what do we get? So in fact, on this graph, you can see on the top graph, you can see the coefficient from this regression taking the number of days that are between 75 and 79 degrees Fahrenheit, 80 to 84 Fahrenheit, 85 to 89 Fahrenheit, 19 to 94 Fahrenheit, and above 95 Fahrenheit. Above 95 Fahrenheit corresponds to above, I think, 32 degrees Celsius, so that's the temperature that starts to be. So 90 is above 32, 95 is the temperature that starts to be really, really hot. So what we see here, so the benchmark, sort of the standard is 70 to 74, very pleasant temperature, in the 20 degrees Celsius for people who are counting in Celsius. And then we can look at the number of days, extra days where people and the number of the mortality rates in those as a function of the number of extra days in the various bins. And what you can see is that, for temperature until 89, the impact is low, but starting from with more days from 19 to 94, we start seeing excess mortality, and that is significant. You can see the confidence bar in dotted dashed line, and then of course above every extra day above 95 days really causes almost twice the number of extra deaths compared to a day above between 85 and 89, for example. That's for India in red. And then below you see the US, and you can see that there is also, the estimates are very, very precise for the US, so you can also detect a small increase in mortality at very hot temperature in the US, but that is much smaller. In the bottom left graph, you can compare rural India to urban India. And you can see that urban India has a lower mortality compared to rural India. And when you're putting urban India to the US, the excess mortality is in urban India is in fact statistically indistinguishable. So just comparing this impact, we conclude that the US is able to protect, so in the US, people are able to protect themselves better from even very, very hot days. That is also true in urban India compared to rural India. It could be for a number of reasons, in particular the fact that in rural India, people are more likely to be working in the fields, so they are more likely to be directly exposed to the heat. They're less likely to be to have air conditioning in their house. They are poorer in general, and so on and so forth. So that difference in excess mortality for the same number of extra days is, if you want, a measure of adaptation. So that's very reduced form, and one of the things we are going to do in the rest of the lecture today is kind of unpack where this difference in adaptation ability in India and the US come from. For another reduced form graph, there is this paper by Burke and others. There is similar work by Melissa Dell and Ben Olken, again using the same type of variation in weather patterns to look at the impact of temperature on GDP. And it shows that for very poor countries, you have a steep gradient around the ideal temperature, which is around something like 20 degrees. When it gets very hot, the GDP is lower. When it gets cold, it's lower as well, but there's a lot of variability in those estimates. Whilst for the rich countries, there is also a gradient, but the gradient is significantly flatter. So similarly, that for exactly as we see for mortality, the rich countries seem to be able to protect themselves better from variation in temperature. So where is that coming from? Well, adaptation costs money. You have or you don't have air conditioning. You can work outside or versus inside. You might be able to import food. Company might have in richer countries might have access to protective technology, which allows them to work even when it's hot, whether they would not be able to do so in poor countries. So to illustrate, these are a picture of Pakistan and Saudi Arabia. The projection under climate model is that they are going to get roughly the same increase in temperature under a moderate emission scenario, but the effect that is expected in terms of extra death, based again on this estimation of the impact of weather on mortality, is much larger for Pakistan than it is for Saudi Arabia. This comes from the work by Carlton, which I'll describe in a bit more detail in a minute, but that illustrates sort of the point. Same expected impact in temperature, but the effect on mortality would be 67 extra deaths per 100,000 people in Pakistan, versus only 35 in Riyadh, Saudi Arabia. So that's kind of a nice insight, and it would be, it's interesting to compare rural and urban India and the US. I'll show you a little later the US over time. What the Carlton and et al. Paper in the QJE does for 2022 is to accumulate panel data on weather patterns and mortality in 25,000 micro-regions around the world. They don't have the whole world. I'll show it to you where the countries they have in a minute. But they have many, many regions across the world, in rich countries, poor countries, cold countries, hot countries, etc. And what they do with that data is that they estimate this two-way fixed effect, controlling for in different bins of historical temperature as well as income. So what you're seeing here is the excess, is again the excess mortality for the number of days that are placed in any given bin. So the excess mortality is expressed in terms of deaths per 100,000. And if you're looking across columns, you can see that, and you're focusing on the right side of the graph, which is the impact of hot days, you can see that in very cold places, the effect, controlling, for example, take the high income, the middle income cold country, will have larger impact of hot days on mortality than the hot country from the hot middle income country. So that's the second row. I don't know if you can see my arrow, but that's the second row, second column. You see a slower uptick here than here. Why is that? It's because the cold country haven't had like a chance to get used to very hot spells. So when they come, they're not prepared. They don't have the infrastructure, they're not installed to do that. For example, in France, when we had the first really unexpected big heat waves in the early 2000s, and a lot of people died because it was completely unexpected. And today, in future heat waves, very few people die because we know what to do. We know that people know that they are supposed to visit older people. They are cooling, even though air conditioning is still relatively rare because it's a temperate country. People still have access to cinemas or to gyms to cool themselves and so on. So that's the first thing, that's natural. But the second thing, and that's what preoccupies us more here, is that conditional on the history on your weather history, having more money is also a way of having a lesser impact of climate change. So if we now look, for example, at hot countries, you can see that the hot countries who are poor still have a pretty big uptick in mortality, in fact, even larger than the high-income countries that are rich. Whereas the hot countries that are rich have very little increase in mortality. So think about a heat wave in Arizona versus Pakistan. In Arizona, they are able to crank up the air conditioning and nobody dies. And in Pakistan, some of them might die. So when we take this curve and we kind of look at then estimate for each place what would be the extra the impact of another day at 35 degrees Celsius relative to the reference temperature in that place in terms of deaths per 100,000, you can see in the top map the countries that they do have. So that's kind of a lot of Europe, Asia, North America, Latin America. They don't have any countries in Africa, so all of the data that I'm going to show you for Africa are kind of simulated. But what they find here is that what they would expect for these cold countries, for these richer countries, is here, and then you can extrapolate as a function of the temperature and the historical temperature and the degree of income in the rest of the world, and you get the map D here, showing that an extra hot day would be extraordinarily costly in Russia, which is both cold and not that rich. But it's also very costly in Africa, even though it is rich, because it is poor. So this reflects the difficulty of adaptation for Africa. Taking into account adaptation, of course, really reduce the impact of climate change on the mortality. On the A curve, you can see here that the mortality effect of climate change without adaptation would be much larger than with adaptation and with the fact that countries are becoming richer. That was kind of the Nordhaus point, is that climate change will be easier when we are richer. So that is true. As countries become richer, they'll adapt in terms of mortality. But despite that, you still have pretty large impact on expected mortality. The overall increase, and these impacts, when you put 2 and 2 together, which is you put the increase in the number of extra days above 35 degrees and the fact that those days are more costly in poor countries than in rich countries, you're getting this map where basically the big mortality cost of climate change will take place in the poorer countries, the whole northern part of Africa and West Africa, the Sahel, etc., the Horn of Africa, the north of South Asia, and so on. In total, what we expect is, or what they expect still from that Carlton paper, is an increase in mortality of at current business as usual of 73 extra deaths per 100,000. If that looks little, 73 per 100,000, it's actually more than all of the infectious diseases combined today. So it's like, getting, and all of these costs are going to be experienced in the poor countries. And you can see that on top of the direct mortality cost, there is also an adaptation cost that comes in, which is the cost of not getting the cost of avoiding this death, and the adaptation cost is the largest in cold climates, naturally. So you can see that was kind of all by way of motivation of why adaptation is really central to understand the impact of climate change, to understand the differential impact of climate change in the developing countries versus richer countries. So how does it adaptation take place? Again, we move back from this kind of reduced form thing to think about what is the form that adaptation can place. So I've already spoken a lot about air conditioning, and that's the first way of adaptation. A first mode of adaptation is to adopt different technologies. Air conditioning being one of them. So there is, I couldn't find a paper on air conditioning in the US, but in developing countries, but there is a paper for the US looking at the dramatic decline in the impact of temperature on mortalities in the US over time. So this again is the same exercise, the impact of a particular day at temperature on mortality rates. And you're finding in 1929 to 1959 a graph that looks very much like the graph that we had for India. But then if you go now from 1960 to 2004, you see a much flatter graph, and of course, as you go on in earlier period, that would become flatter and flatter, as we've seen earlier. So the impact of a given very hot day has become much smaller over time in the US. So there could be a number of reasons for that. So what they do to find out or to at least to get some sense of what these reasons might be, is that they run a similar regression to what I showed you before, which is a two-way fixed effect, but they interacted with various stuff that could modify the impact of climate change. So what you want to know is whether a particular hot day has a bigger effect in places that have some characteristic versus another. They put any number of things in there: electrification, labor markets, and so on. But the one that they zero in on as being the most likely to explain this dramatic decline is air conditioning. And in fact, when you look at, so this is plotting this interaction over time, and this is plotting this interaction over various temperature bands. And you can see that at 90 degrees, having more air conditioning in the regions really reduced the effect of a hot day on mortality. Remember, there is a main effect of the number of hot days. So it's not saying that if you are conditioning, hot days actually reduce mortality, but they increase mortality much less when there is a more penetration of air conditioning. So air conditioning, of course, they are, this is to take with some amount of salt, because many things could be correlated with air conditioning. They do a bunch of things, including looking at the exact timing of when air conditioning were introduced in a lot of places, and ultimately are convinced, and at least were convinced me, that air conditioning played a fundamental role in the decline in the impact of hotter temperature on mortality in the US historically. So what does this mean for the US? Well, the US can also get, the other countries can also get air conditioning. This is a photo from India, where you can see that air conditioning units are plentiful. In fact, air conditioning is a huge kind of bone of contention between countries in negotiations, in climate negotiations, because air conditioning machines themselves have contribute to climate change, in particular the old machines, such as the ones that are here, and at the same time they protect people from climate change. So let's think a little bit of that. So as countries become less poor, one of the things they will want is to have more air conditioning machines. You can see that this is cross-sectionally from Davis and Gertler. You can see that the richer the country is, the more air conditioning they have. The share of households with air conditioning increase really, really fast with the GDP of a country. So one of the things you would want to do if you're a poor country is to become less poor as quickly as possible in order to afford air conditioning for your households. This is another other data set saying that says the same thing. This is now not across country but within country, showing that households that are richer are more likely to have air conditioning machines, as well as other electrical machines such as television, washing machines, etc. So there is a steep gradient in access to electricity demanding things, in particular air conditioning units. And then, of course, once you have air conditioning, if it's hot, then you're using air conditioning more. So this is actually data from the US looking at variation over time in the number of hot days, a little bit like your mortality regression. And very naturally, the more hot days, the more electricity demand. That's to power all of these air conditioning units. So this really highlights a central tension, which I'm not going to spend much more time on today, but is really key that we really need to have in the back of our mind at any point, which is that there can be a tension between adaptation and mitigation. And some of the adaptation measures are themselves anti-mitigation measures. For air conditioning, of course, the first order is the electricity demand is important. So you can see here other data from the Climate Impact Lab looking at electricity demand from various countries in different climate, due to different climate scenarios. Again, using the fact that when it's hot, you're using electricity more. You can see that in the current scenario, the US will increase its electricity demand by 2.7%, 2.7 of a higher level. That's a lot of energy. But China will increase its demand by 9%. India will increase its demand by 145%. So that's a lot of extra electricity that start to be registerable on a graph. So India, which is a poor country, will start registering on the map. You can see here Nigeria, 2000% increase in electricity. So depending on how that electricity is generated, that may contribute to the problems. You might remember the fact that the COP, India and China at the last minute in the COP in Glasgow did not sign a declaration saying that they were trying, an objective was to win themselves out of coal. China was not a surprise. India was a bit of a last minute surprise. And when they were criticized, the explanation was like, what are we going to do? We need the electricity to protect our citizens. Another direct, even in some sense, more direct impact of air conditioning units on climate is that the air conditioning units that are the cheaper air conditioning units generate fluoride, which are themselves terrible for irrespective of the electricity that is used. They are themselves a very bad greenhouse gas. And there was an accord in Kigali several years ago to limit the the spread of those machines, but it left India and China until 2024, I believe, to continue manufacturing them and distributing them. That's because they are cheaper and they can be produced locally. So for them, for India, it made a lot of sense to have those machines distributed. On the other hand, that's contributing to the problem. So you can see this tension, which of course it should be taken into account when we're thinking about how we deal with the developing world and the legitimate need for adaptation against the problem of making the problem worse. So AC is one technologies, but that's not the only one. There are a lot of technologies that are potentially available to countries to change their pattern. Countries could use better crops. They could introduce irrigation when it was not there before, or change the irrigation methods. Crop diversification is another method. There is here, I'm not going to spend much time on that, but there is a paper by Donaldson and Costino looking in general equilibrium effect about the impact of climate change on global worldwide agricultural production would be without adaptation and with adaptation. They are allowing adaptation to take place in the form of crop diversification, so changing the crops to be appropriate to the local, to the new pattern of weather that will come with climate change, as well as trade. And what they show is that basically the most important part is the crop diversification adoption of new crops that are more appropriate to the new condition. And then there are also, and that's the one I'm going to spend a little bit more time on, there are places which are so severely degraded today that you cannot plant on them with traditional methods, but new way of planting can maybe allow to cultivate these areas. One issue with all of those technologies, new crop, new seeds, new way of planting, is that they require two things. They require money sometimes to pay for labor or to pay for new seeds, as well as information that it makes sense. They also require potentially tolerance to risk in some cases. So, for example, in the case of adoption in the case of new seeds, Richard Glenster, Tavnit Suri have a paper on drought-resistant improved rice in Sierra Leone, showing that it is effective, but the take-up is very low and limited by people's access to training and to how to use it properly. Similarly, in very degraded areas, such as Niger, for example, there are method of kind of re-putting degraded land into production. There are various examples here, Zai, Tassa, Banquet, and Demi-Lune, which exist, which shows that they can restore degraded land, increase land use, increase yields, but the adoption level remains very low. So Kelsey Jack and Jenny Acker have a paper you're looking specifically at one of those technologies, the Demi-Lune in Niger. And they are looking at two things. They are looking at potentially the financial barriers to adoption, as well as technology, the fact that people are not necessarily aware of those technologies. And what they're finding is that the training, just simply telling people how to do it, has huge impact on take-up, and but giving people money, not too much, which means that just training people turns out to be a very cost-effective method to improve the take-up of that technology. It's not necessarily a generalizable finding outside of this one. This is really a place where you could do nothing and then you can do something. So it's not that you are improving what you have, it's that you're literally, getting a first order increase in your production. But it's relevant and encouraging, especially given that the impacts are large. 3 years after, 3 years after the training, the farmers who have been trained see are twice as likely to have brought some land into production. The soil is less likely to be degraded and without vegetation. The soil quality has improved, vegetation has returned, water is being retained. So it seems feasible. Training is most cost effective to increase the adoption. And if you want to increase production the most, giving unconditional cash transfer on top of it is the most cost effective. Once these methods exist, it becomes possible to scale them up. So just to say that this is not just kind of research. Jenny, Kelsey, and others are also working, or were working, I don't know where we are on Niger right now, on the scale up of those technology. This is a program that's not particularly expensive, which in this case show high effectiveness. So there is an effort to scale up, and in the process of scaling up, also understand a little bit better how to streamline this program for scale, what component of the trainings are really essential, and how to make sure that it sticks when it's done in the long run. So this type of effort of not just observing while adaptation takes place, but conducting research on what will help households adapt in various settings. So the Niger setting is very extreme and very important, because this is one of the places where people are the most affected by climate change. Is, I think, a very productive area of research, quite underused right now. So the first thing they could do is to adopt this new technology. Second thing households can do is to simply change activity. So if it's too hot and you cannot grow anymore, then maybe you should just do something else than what you're doing now. An example of that, of the need to change your pattern of production, is rice in Punjab. So Punjab is a state in India where historically rice was not produced, but which has become, from independence, the granary of India, with huge production of rice. You can see the increase here over time in the rice production from the 1970s to the early 2000s. But this rice is produced 100% with irrigation. I don't know if many of you probably have seen rice. Rice likes to be feet in the water and a head in the sun, like a child on the beach. So in order to put the rice, the feet in the water of the rice in Punjab, you have to have irrigation. And the way the irrigation works is through groundwater irrigation. And you can see what this has done to the groundwater depth over time. Unfortunately, the groundwater gets depleted about 50% faster than it repletes, than it regenerates through water. So over time, the groundwater is deeper and deeper and deeper in Punjab. So how come farmers are able to dig deeper and deeper to get the water and to continue to irrigate and to continue to increase their production? That is because they've traditionally gotten free electricity, and they get free electricity and they use it. The very important work by Nick Ryan and showed that it's not that they're wasting electricity. Often we think, oh, they are since the electricity is free, they are just wasting electricity and water. It is free, but it is rationed, so it's not that they get as much as they want, and therefore at the margin they have no incentive to waste it, and they are not wasting it from their private calculation. So this is comparing the cost and benefit of a bit more of electricity from a structural model. We don't need to go into the detail of how it's done, but it is worth reading that paper. What you're seeing is that the marginal benefit of a bit more electricity is still higher than the marginal cost. Unfortunately, the social cost is high because it takes into account the fact that over time the water depletes. So how big the social cost is depends on how patient or impatient you are. So if you're extraordinarily impatient, the social cost is about the marginal benefit. If you are patient, which I agree, you should be patient, probably more than a 95% discount rate. You should be more patient than that because we have the future generation to think about. And once there is no water, there really is a pickle. Then you can see that the social costs are higher than the marginal benefits. So just from water point of view, basically, so without this water, the rice farmers shouldn't be producing rice. We're seeing that it's not worth it for them to get this water. So I think a logical conclusion is that it's worth for them to stop producing rice. And there is another reason why it's Punjab farmer in Punjab should move away from rice, or at least diversify away from rice, is that the way that rice is being produced traditionally, it's not the only way, but that's the way it is working today. The rice stock is being burnt, and then that is in part, not only, but in part responsible for all of the suspended particulate matter in the air that are turning Delhi into irrespirable atmospheres, as well as, by the way, contributing to climate change. So just from pollution, the paper by Rohini Pandey, Kelsey Jack, and Namrata Kala and Seema Jayachandran on this question of crop burning conclude that the social value of rice production in Punjab is negative. So there are two reasons why it's negative. It's because it's using water that is extraordinarily expensive because soon it's going to be gone, and that is because it's polluting. So the logical thing to do for Punjab would not be to produce rice differently, it would be to go back to what traditionally was done, which is do something else. So produce millets or produce things that require less water or things that are much higher value, such as vegetable. But it's been very difficult for farmers to do it. They haven't really done it because the entire value chain system is organized around rice production and not very organized for doing something else, for doing other things. So you can see here rice production over time in Punjab. It's not really decreasing. It has stopped increasing, but it is not really decreasing. 2021 was close to the maximum of bumper harvest of 2018. So in Punjab, it's not happening yet, but that's clearly a measure of adaptation, a way of adaptation that could happen in the future. And it is possible for this to adapt. When the wells completely fail at the household level, this very nice paper by Blacksley called Way Down in a Hole looks at another place in India, further in the south, and looks at the very micro level at what households do when their borewell fail, when there is no water under it. So that happens, that's a little bit, when the water table falls down. It's not that everybody becomes dry at the same point, because it really depends on where you happen to be relative to to where the source of water is. So people who are very similar otherwise might have a borewell that have failed or not. So what they're doing in this paper is that they're comparing household before and after and around, or this is a use of whether or not you have an operational borewell, looking back historically, when you constructed your borewell and then you have a failure in the borewell, you're less likely to have one. Some people make another one, but a lot of people don't. So then what they are doing is that they are comparing households with failed borewell and without failed borewell. And what they show is that people who have a failed borewell have much lower income from agriculture, on-farm income. And what they do is that they substitute by working more off-farm. So they are not changing what they produce, they just change what they do altogether. And the off-farm employment almost entirely compensate. One way in which you can change your activity is to migrate. I'm not going to talk about that at all because that's going to be a lecture you're going to get later in the semester. The fourth way in which we can adapt is by using financial products to smooth those shocks. So these are loans, insurance, etc. Let me start with loans, and a paper by Fink, Jack, and Mazier, looking at Zambia. Again, this is not really a reaction. This is not using loans to react to adapt to a shock. This is using loans, or this is the power they show again, the power of loans to adapt to a structure, to a situation where structurally there is a dry season. And of course, as climate change takes place, there will be more regions where structurally there is a dry season, and the dry season will be drier. So in a lot of countries, those seasons exist. In Bangladesh, it's called Monga, or the hungry season. And in this place, in Zambia, people are severely credit constrained. So what they do during the dry season is that they sell their labor and they work on other people's field, if there are people who are rich enough to hire people, or on various off-farm employment. The problem with that is that when you is that in that they don't have time, because they're working elsewhere, they don't have time to be working on their own plot, and therefore to make the plot ready to be more productive during the harvest season. So this is another paper, and you can see the kind of trademark of Kelsey, which is not just to observe things, but to test the various ways to make them better, to help farmers adapt to this hot climate, which produces this predictable seasonal pattern, is a seasonal loan that is offered to households. This is randomized. It's a loan, so they are supposed to reimburse it after the season. And you can hear what I show in the first line is the comparison between, this was done as a randomized control trial, so you compare households that got and did not get that loan. You can see that the households that get the loan were less likely to do GANU, this off-farm labor, of their own farm labor. They sold less. They were more likely to hire GANU on the other hand, and they hired more hours. As a result, there was more and in addition, there was 5 more family hours on their farm. So if you take into account this plus this, 7 more hours per week, 7 more hours spent on the farm. This you would expect would give them a chance to produce more, and in fact, indeed, you show larger agricultural production, and as a result, a better, a higher consumption, both in the lean season and in the high season, with fewer months without enough food, with higher food security, with less hungry, more meals per day in the hungry season, and no change in the harvest season. In addition, so this is about an example, and that's not the only one of the power of loans. Burgess and Donaldson and Greenstone show that the effect of temperature on mortality is mediated by the presence of banks. So that's another way in which banks seems to be making a difference. The problem, of course, with climate change is not just that the temperature level are changing, but also that the volatility of temperature and disasters change, including flood and coastal damages, because a lot of countries have a lot of flood and a lot of very low-lying area. This is pictures from Pakistan. So what do people do? Like an adaptation mechanism is we have to adapt to these shocks. Traditionally, households rely a lot on informal insurance against the shock that they experience in their lives. This is, for example, famous work by Townsend. However, this kind of informal sharing is less good for aggregate shocks because, well, everyone is expected gets the shocks. If you look at the photo from Pakistan, it's not that your neighbor is able to help you because your neighbor's house is also underwater. There are new technology that helps. For example, mobile money, and we'll talk back about mobile money for another application in a minute. Tavnit Shuri and Kelsey Jack show that in Kenya, when mobile money gets more widespread, the households who benefit from it are better insured against various kinds of shocks, idiosyncratic or aggregate at the local level, because they have many more people around the country that can help them. So that is great, because even when there is a climate change, it's not everywhere in the entire country. So having access to a more diversified network of solidarity might really help people. That's a form of adaptation. Still, it's unlikely that it will be enough for large shocks caused by the increased volatility of transfer. So for that, we should have insurance, right? And in a way, insurance is always kind of has long been perceived for the next frontier of financial services for the poor, and even more in a world of increased risk. I'm a bit skeptical of the role of the role that private insurance can play in protecting households, because the results of the extensive research on insurance shows that yes, when people have access to insurance, they feel better about it. So this is a paper from Dean Carl and Chris Udry and Robert Osei, randomly offering insurance at very subsidized or free, showing that people that have access to insurance are more likely, and credit as well, are more likely to invest in their land. They cultivate more, they use more fertilizers and so on, and they produce more at the end. However, they also show in the same paper that the demand for insurance at an actuarially fair price, which is 14 Ghana cedis, is very, very low. So people basically are not interested in getting insurance at the price it would cost to actually provide it. There is a number of reasons for that. One of them is I illustrated in a children's book that I wrote recently about the fact that when you come to ask for to be reimbursed for your insurance, there is often a hole. So there is a lot of business risk. So here the insurer is explaining the family that lost their boats in the flood that their product didn't cover a flood risk, just drought risk. So if private insurance isn't going to do it, then it's really social protection that can do it. So the government has to step in and play this role. So ultimately, governments need to have the possibility to help their citizens adapt to climate change by supporting them in period of crisis. Fortunately, there is now plenty of evidence that cash transfer can be put to good use in general. During COVID years, there have been several experiences forced by the circumstances in targeting and logistics of doing cash transfer through mobile money. For example, Togo set up a program called Novici in just about 2-3 weeks, innovated with a new way of targeting household at a geographical level, using satellite map to identify the poorest area, and then using cell phone metadata to identify the poorest subscriber. They worked on this with IPA and with Josh Blumenstock and Dean Carlin and Chris Udry. So these kind of methods can really be scaled up and put in place. So basically, countries are prepared. They can, when a disaster strikes, everyone should be and could be within striking distance of a transfer. Even better than that are anticipatory cash transfers, which is there is a lot of work using machine learning, artificial intelligence, of improvement in predictions of where a disaster might next occur. At JPL, we are working with a team at MIT and BRAC that does it, called CruiseNet, but there are many other systems. Google is working on it as well. So if you are able to know better when there might be an incident, for example, a flood or an extended period of very hot weather, then you can help people proactively, which, for example, might give them the money to live and to protect themselves, or to do something to protect their houses. So an example of that by Popel et al. A recent example is anticipatory cash transfer done by the World Food Programme to households that were going to be flooded. Because of the COVID pandemic, there was a lot of logistical difficulty in carrying out this program. So some people who should be eligible got it and some didn't. So what they do in this paper is comparing people who got and didn't get it. People look pretty similar from at the beginning. And they find very positive impact of getting these transfers on all of the outcome that they measure. Preemptive action, child food consumption, asset loss index, less borrowing, more earning potential. And finally, that's not about protecting people from shocks, but again, we saw that income is protective of climate change. Conversely, being extraordinarily poor is a huge risk factor, as people live outside, are dependent on the generosity of others for surviving and so on. So being an extremely poor person in subject to either increased temperature or the shocks related to climate change is literally deadly. So it's pretty essential to not let anyone fall in extreme poverty, especially as climate change will create that risk. And that's where the ultra-poor programs, such as the one that was pioneered by BRAC and evaluated in many countries, including India, can really help and can and should be scaled up. So here I gave you some example of the impact at 10 years of ultra-poor program in India. That program is being scaled up in the poorest state in India, in Bihar, for example. And that program has a lot of potential to help the very, very, very poorest adapt to climate change. So let me stop here. Adaptation will take money, both for individual citizens, but also for countries. Without help, countries will look to the shortest way possible to adapt. So adaptation may fight with mitigation unless it is well managed. And doing this together as a world citizens is both the fair thing to do, but also probably the efficient thing to do. Thank you so much for your attention. As mentioned, there will be a Q&A session now. Unfortunately, I have a seminar I have to attend to right now. So, but you are in very good hand with Veronica, who will take your questions. And the slides will be shared on the website. So that's one question you don't need to ask. And I wish you the best in your research and any endeavor. Bye-bye.
Thank you so much, Esther. Veronica, the floor is yours. If you have questions, please put them into the chat as you have been, and those that are live will have opportunity to raise their hands and ask questions as Veronica directs. Thank you.
Hi, everyone. Thank you so much for attending. This has been a fantastic session, and I've been trying to get my hands on as many questions as I've been able to, but obviously there's loads, so I apologize to those that I haven't been able to. So what I'm going to do is, first I'm going to take 3 questions live so that you have a chance to speak and I can see your faces, and then I'll try to address those, and then I'm going to group some of those in the chat that I think touch on similar themes that I haven't answered yet. So you want to raise your hand and I'll give you floor. So we have Kavita, Karina, and is there a third? Otherwise, we'll just go with Kavita and Karina. Yeah, Kavita, do you know? Ask your question?
Yeah. Hi. So I had 2 quick questions, mostly on the institutional enabling conditions sort of angle to adaptation. One is on more generally how evidence-based economic methods can be used to understand the role of either institutional failures or institutional capacities, not just at the local sort of from between communities level, but at a bigger scale level. And the second is on the role of international or bilateral, multilateral funding for climate change adaptation, especially in countries, low-income countries don't have adequate institutional economic capacities to absorb finance. And because they have adaptation in general has a cost benefit mismatch to it. So because adaptation takes money, I'm just trying to see how we at least think about it. So those were my two questions.
Okay. Yeah, excellent questions. And Karina, do you want to ask yours? And then
so Kavita's questions I feel are very aligned with my questions, which is good. Like what Kavitha mentioned about institutional aspects, I was wondering if how we could very clearly link fiscal aspects to these results. So I do know that right now there's sort of a hype around green budgeting and around federative schemes that could exist to transfer money from national to subnational governments, and how, because the effects are happening at subnational level, right, at people's doorsteps, but you have sort of national governments trying to coordinate these climate adaptation efforts, or international level governments. So how if you've seen different links being done, if you could maybe reference them. And also there seems to be a difference between what are the main social challenges faced by different countries given climate change effects. So for instance, in Brazil, the northern part of Brazil, which is where I'm from, northern part of Brazil has a lot of issues regarding just water. Like we have lots of water, it's just very difficult to get things there. And then as the volume of water increases with climate change, then there's a problem with access. But the southern part of Brazil is facing also floods, which it wasn't generally facing, which is the opposite of what the northeastern of Brazil is facing, which is droughts. So how would you try to sort of put all this into one pack in terms of evaluation, because these are very heterogeneous effects? And well, there you go. So.
Okay, no, those are excellent questions, and they're sort of in line with some of the themes that I got from the chat. So with regards to how would I try to put it onto one pack, I wouldn't. I think it's really important not to put it all under one pack. Climate change is a problem that has a common source, increased greenhouse gas emissions, but it has all these multifaceted impacts. And it is very important to be aware of that and to sort of target specifically each question. I mean, yeah, I'm sorry, it's very hard to give blanket solutions. And I think that's precisely what we should not attempt to do, because it's gonna block research. And it's good to be context specific and look at the specific problems that people are facing. How to use evidence-based policy when things happen at more, let me see if I'm understanding this question, Kavita's question correctly, when solutions, and this, I got some questions about like kind of private actions versus more collective institutional solutions. And from the point of view of evaluation of these policies, yeah, sure. If it's implemented at a large jurisdiction, you're gonna need kind of a larger scale to have power, and it might pose some questions. So it's worth looking at a sort of clever identification designs that maybe, or you might have to do it at the level of a higher jurisdiction, or yeah, the design of the precise design of the implementation might be special. But I think it is very important sometimes not to be tied by the identification strategy that you want to use. Maybe easier to implement for individual solutions, but maybe some questions will require more institutional solutions at higher jurisdictional levels. So this is a really important point. I think probably there's need for both, and they will need different evaluation strategies. On yeah, there were many questions about this sort of, okay, what about more institutional solutions? What about institutional barriers to the implementation of insurance schemes? These seems like they're all crucial issues. There's going to be a little bit more discussion, I think, specifically about this, or a good session that you should definitely attend if you're interested in this would be the regulation and pollution with Rohini Pandey, who looks more at the political, like, yeah, public fiscal side of things. The yeah, please feel free to follow up, or someone else jump in. This is kind of meant to be a discussion. Obviously, I'm not going to answer how do we solve all the issues associated with climate change.
No, I think that's great, Veronica. Were there any clusters in the Q&A that you wanted to shift to?
Let me see.
There was perhaps one that stuck out to me about maybe the trade-off between adaptation through different means, but also the emissions that those adaptations can cause, whether through air conditioning or through other forms. And maybe if you could just touch on that briefly.
Yeah, I can touch on that briefly. So there's an ethical dilemma when you think that adaptation is going to cause additional emissions. My personal view is that it's not that complicated of a dilemma if you think about the historical emissions caused by poorest people. Of course, the ideal is to not have a zero-sum mentality and think it's not either or, you should try to adapt in the less emitting way possible. But when it's saving a life or not saving a life, and it will require increased greenhouse gas emissions, to me, a solution is clear, especially when these people and these countries have emitted so much less. That's why there's so many provisions for this in international climate agreements. I think it's interesting to look at maybe when in some cases it could lock you into higher emission pathways in the future, and when it's like more of a one-off thing, if that makes any sense. So if it's like building infrastructure that would lock into emitting for a long time in the future, that would be different if it's something that would emit in the short run, but not necessarily lock a country into emitting more in the long run. But yeah, I mean, as Esther was saying, that is a central tension. And I think it is worth remembering that the reason we want to stop climate change is to save people's lives. So if we can save them from climate change now, we might as well just do that. That's my 2 cents on that. Any other questions that stuck out to you from the chat? I think there were.
I'll have another quick look, but it looks like Juliet might have a question here in the participant.
Yeah,
I just wanted to follow up. I find it so interesting. The question is like, would you be on the side of, say we manage to have like 100% adaptation to climate change? Is it preferable to do that, or and just forget about mitigation, or like still try to have half mitigation, half adaptation, when mitigation pretty much basically, given the political constraints, we're just postponing every day, we have a time inconsistency issue. So I wonder if if it wouldn't be better to just say 100% adaptation and we forget about mitigation. But that's a tough, thorny question.
It's a good thought experiment. It's probably not possible, isn't it? We are still very much dependent on what the earth produces, and if we kill it all, I don't think we will have anything to work with to adapt. So unless we learn how to make fossil fuels into food or something crazy like that. I think it's kind of a pointless thought experiment. Yeah, that's kind of my take. I mean, then then there come questions about where we should have ethical obligations towards non-human beings, and can discuss that, but I think it's not even necessary to go there, because I don't think we can do 100% adaptation without mitigation.
I feel like, and I would be super keen on having your opinion on this. I feel like people don't really see the benefits of mitigation versus they would see more the benefits of adapting. Whereas mitigating, I guess they don't really realize. Like, what do you think of this?
So I think there's a very promising research agenda in the space, has to do with like all the co-benefits of mitigation strategies. When you think about local air pollution, when you think about sort of, there are so many ways in which destroying the environment has direct effects for human health. If you look at all the effects, the local effects in health of mining or of different activities that maybe you don't need to think only about their effects for climate change. There are sometimes tensions, but there are sometimes very large co-benefits from seeking the more environmentally friendly way of doing things. It's kind of a, yeah, I guess that's the game, kind of trying to find the win-wins when they exist, and thinking about fair ways out of the trade-offs as much as possible. Like, yeah. We have 3 more minutes. If someone else wants to, any comment, any, like, if you want to answer a previous question. Yes, Jasia?
My question is related to the adaptation. As women, I guess like they are the poorest of the poor and they don't have enough money to do the adaptation. So do you think in the developing country that's going to be a big deal because women do not know or do not have enough resources to do the adaptation?
Yeah, it's very important to have a gender angle to this. I agree, especially women are often the ones collecting water in the developing world. That's a big one that is important to look at. Do you have, I guess, specific thoughts in mind about how climate change affects women more severely, I guess? Yeah. It would be interesting to hear from you if you do have thoughts on how you think adaptation is particularly difficult for women.
Okay, I did a public good game in my country, Bangladesh, and where I compared this public good game with the altruistic game, and found that in terms of the public good game, people expect women to contribute when it's about the future generation, intergenerational game. The women were not much expected to contribute there as it is about the donation. That was the finding, and the perception and the reality was very much aligned with it. So when you use a term like intergenerational and altruistic game for future generation, the women do not have the authority or the agency to spend, but about their own generation, about the public good game, in terms of adaptation, the result shows that like women are as cooperative as men in my result. Yeah.
Yeah, that is actually very interesting. It's a very interesting angle on like the gender differences in adaptation, and maybe there's different expectations around how women are going to behave and whether they're going to sacrifice themselves more for others. Yeah, that's fascinating. Thank you for sharing.
You're welcome.
I think that we're probably going to have to stop there. Thank you so much, Veronica, and to all of the participants. Just a reminder that next week we have our lecture on renewables by Mar Reguant and John Van Reenen. Same time, same place. And just to sum up a little of what was talked about there, that as discussed are short and long-term trade-offs that we have to look at, and with the context-specific nature of the problem at hand, it's sticky and it's messy, but we really appreciate all of your efforts and research and hope that you can find new answers that we can talk about in the next few weeks and months. So until next week, thank you all.
Thank you. Thank you, everyone. Bye.